Today's lesson is about learning how to use logs kind of in real life situations. We're going to look at some population growth, some decay, and some different money situations. So here we go. All right. The population of Biwabic, Minnesota is 2,500 people and is increasing at the rate of 6.75%. I'm not sure where that is or what is going on with that town, but supposedly it's increasing at 6.75%, which is a lot. Approximately when will the population reach 10,000 people is the question. Okay? So whenever you're dealing with growth and decay kinds of problems, you're going to use this general equation right here. P, of course, is the amount that you start with. A is how much of that item, in this case it's people, remains each year. So obviously if it's growing, you want to throw a 1 in front of it. If it's decaying by 6.75%, then you would take that 6.75% away from 100. Of course, the x is how many times that it gets compounded. And then the y would be the ending amount. So in this case, this is kind of the equation that I want to set up. I want to end with 10,000 people. I started with 2,500. Notice I have the 1 in front of the 6.75% because it's growing. The 1 will give you the 2,500 people back again, and then the 6.75 on top of that makes it grow by 6.75%. Okay, and then of course, to the x, we don't know how much time it's going to take. Okay, so x in this case is time, and we don't know that. So I'm going to solve this equation. Obviously, I can divide by 2,500 to solve, and that will simplify this here. And I will get 4. And of course, I cannot get 4 and 1.0675 as the same base. I can't do that. So I need to have a way to solve this. So what I'm going to do to solve this is I am going to take the log of both sides. So I will take the log of the left and the log of the right. And so then, of course, we know by log properties that this x can come out in front, and I will have this. All right, and then to solve for x, I will divide by log of 1.0675. And x will come out to be about 22.22. And in this case, it's growing yearly, and so it'll be about 22.22 years. Okay, a little over 22 years until it reaches 10,000 people. All right, same kind of deal here. This time you're investing money. It's growing at 6% interest, and it's being compounded annually, only once a year. So when it's only being compounded annually, you can use this simple interest formula here. You don't need to have that one that's 1 plus r over n to the nt. That's what you're going to use if it's being compounded more than annually, more than once a year. But here, if it's only being compounded once a year or annually, you can use just this simple interest formula. The question is, how long will it take to double your money? The problem is here, too, it doesn't tell you what your initial investment is. So I don't know what my initial investment is. It doesn't give me a dollar amount, but I want to double my money. So I know that what I want to end with is 2p, okay? It's growing at 6% interest. I need the 1 in front of it so that every year I get the amount of money I had in there back plus 6% more. And then, of course, I don't know how many times I'm going to compound it for, okay? Or how many years in this case. So I want to be able to solve for p, so I divide by p. Of course, my p's will cancel, and I will have 2 equals 1.06 to the x power. Again, I can't get 2 and 1.06 as a common base, so I'm going to need to take the logs of both sides. So I take the log of the left and the log of the right, and of course the x comes out in front. So I will have log 2 equals x times log of 1.06, and then divide by log of 1.06. And I don't know what you get for an answer here, but I can stick that into my calculator and check for you. Log of 2 divided by log of 1.06. Should give you about 11.9 years or so. And of course, then if it's being compounded annually, really it should say 12 years because it's only being compounded once a year, so it would take till that 12th year for that to happen. All right, then there are situations where interest is compounded continuously. And this is the formula that you will use to compound it continuously. This formula is a little bit different that when you plug the rate in, you don't add the 1 to it, okay? So I want you to notice that. But this is what's happening when it's compounded continuously. Special formula for that. If it's being compounded more than once a year, then you use that 1 plus the r over n formula, but continuously is this one, okay? So in this particular example, we are investing $2,300. It's being compounded continuously at 4.3% interest. And we want to know how long it is going to take to reach $5,000. So our ending amount is $5,000. Our starting amount is $2,300. E is just a number. You're not going to plug anything in there. It's a variable. It's not a number. Or I mean, it's a number. It's not a variable. The interest rate in this case is 4.3%. So you're going to write that as 0.043. Again, do not add the 1 to it when you're dealing with this formula. And then, of course, I don't know time. That's what I'm trying to figure out. Okay. So I will divide by 2,300. And I am just going to leave this as 50. This will reduce. The zeros will cross out, and this will reduce to 50 over 23. And then, of course, I have this e to the 0.043t. I can't get e and 50/23 as a common base either, so you're going to do the logs. Because you're dealing with the number e, you're going to use natural logs instead of regular logs, so you're going to take the ln of both sides. And of course, then you're going to take this and put it out in front because that's a rule. So I have the natural log of 50/23 equals 0.043t times the natural log of e. And of course, we know that the natural log of e is 1, so I don't need that there. And to solve for t now, I will just divide by 0.043. And t will come out to be, sorry, I don't have this calculated again, so I have to stick it into my calculator, but you can check yours. The natural log of 50/23 divided by 0.043 should come out to be about 18.06 years or so. Okay? All right, now we're going to deal with half-lives. I know you dealt with these a lot in chemistry, and physics maybe too. But half-life, basically, so you know, is the amount of time it takes for half of the substance to be gone, or to, in this case, change to a non-radioactive state, okay? When you're dealing with half-lives, you're going to use this general kind of interest or growth and decay equation right here. X, when you're dealing with half-lives, is X stands for the number of half-lives always, not the number of years, not the number of whatever, but you will use this general equation. X is the number of half-lives, okay? When you're dealing with 50% of something, then that means the rate is always 50% or 1/2. It's always going to be 0.5 for half-life problems. So whenever you see the word half-life, you know that the A will always be 0.5. Okay, so we are going to do a problem like this and go from there. Okay, so the half-life of elfsonium is 20 days. Again, half-life gives you a, it might not give you a number right there, but it gives you a hint as to what rate you're going to use, which is 50% in this case. So the half-life is 20 days, and you obtain 5 precious grams. When will there only be 1 gram of the substance remaining? Okay, so the initial amount is 5. You want to end up with one substance. The rate we will always use when we're doing half-life problems is 1/2. And of course, I don't know x. Okay? So to solve this, you can't take 5 times 1/2 and get 5/2 to the x power. You don't want to do that because your PEMDAS rules are that you have to take the exponent first. And so when you're trying to solve that, you have to do the opposite of that. So we would need to divide. So I have 1/5 equals 1/2 to the x power. And of course, I can't get 1/5 and 1/2 as common bases either. So then I will take the log of both sides. And then this x that's here will come out in front. So I will have the log of 1/5 equals x times the log of 1/2. And of course, to solve for for x, I will divide by the log of 1/2. And then those will drop, and I will stick that into my calculator, and x will come out to be about 2.32. Okay, now remember when you were doing half-life problems, the x, or the time that's here, is the number of half-lives. So you have to pay attention to what the question is asking you. Does it ask you how many half-lives it will take, or does it ask you how much time it will take? So this 2.23 means 2.23 half-lives. Okay, now each half-life is 20 days. That's what it told you from the beginning. Okay, so it's going to take 2.32 times those 20 days, because that's how much a half-life is, which of course will give you about 46.44 days. Okay, so that's how long it will take. All right, and that will be it for this time.